Welcome back to the GCSE Maths Pro YouTube channel. Today's video is on perimeter with algebra, which is the final part of the perimeter topic. If you haven't already checked out all the other videos on perimeter in the first place, definitely make sure to go and look at those beforehand. Otherwise, not a lot of this video will make sense. You'll find them all linked down below in the description. For this video, what we're really looking at is questions where we're likely to be given the perimeter as our answer. They've actually told us this is the perimeter, and they want us to work backwards to find out maybe one of the sides, maybe a radius, something like that. So we're actually going to be using algebra in terms of creating equations that we can then quite clearly see how to reverse or unpick to work backwards. In this case, we actually have got x in there, and in the exam they might put x or another letter in there so that you are kind of prompted to use algebra. So the perimeter of the rectangle is now 38. So we've been told the perimeter is 38 centimeters. Work out the length of x of the rectangle. So we've been told one of them is 7. So I would kind of label this rectangle, go, right, okay, well I know opposite sides of a rectangle are the same. So that is also 7, isn't it? And then the opposite side of this height here has to also be x. I'm going to label them both x because, well, they are the same, aren't they? Then I'm going to go, okay, again, let me pretend that I'm writing down the perimeter. So if I were to work out the perimeter, normally I would do, okay, 7 plus x plus 7 plus x. And I know, I've actually got the answer. I know that that's 38, isn't it? So again, do you see how I've got this scenario where I've got an equation? And I'm just going to simplify this and then solve it. So for now, the left side's not much to do with that. On the right-hand side, let's collect the like terms, which means looking for things that are the same in terms of the fact that we've got 7 and 7. They're both numbers, so I can add those together. That's 14, isn't it? And then I've got x and x, which are both x's, so I can add those together. When we're adding, we're just counting, so we've got 2x. So I've simplified it to be 38 is the same thing, or is equal to 14 plus 2x. Now I just want to solve it. I'm actually almost forgetting about the fact that the context is a rectangle. At this point, it's just algebra. To solve an equation, you want to get x, or whatever letter it is, on its own. So I need to move the 14, and I need to move the 2. It doesn't technically matter which one you do first, but I'm going to move the 14 first. I always find that easier. And the way that we move things algebraically is by doing the opposite. So currently the 14 is just like a positive 14. It's just added there. So I'm going to minus 14 from both sides. And that's how it kind of moves across to the other side of the equation, isn't it? So I get just 2x because I've obviously cancelled out the 14. 38 minus 14 is going to be 24. And I'm left with 2x is equal to 24. At this point, you might be able to guess it. But again, I'm just going to go with that logic of, okay, how do I move the 2? Well, 2 times x. So I need to do divide. Divide by 2 on both sides. Now let me bring it up here. So I get obviously 2x divided by 2 is obviously just 1x, or x in that case. And 24 divided by 2 is 12. And it says work out the length x. And we've got that. X is 12 centimeters, isn't it? So your answer is 12 centimeters. Now, you don't have to, again, you probably don't have to do it that way. You could just figure it out and go, oh yeah, I know that I'll just take away the 7s and then I'll half it. Like, you might be able to just visualize it really well in your head without using algebra. In which case, that's fine. Again, if you get 12, then that's fine, whatever method you use. But if you like to use algebra to make sense of things, there's the working. Okay, again, we're getting a little bit harder again. So the perimeter of the rectangle is 64 centimeters. The length of the rectangle is 3 times the width. Work out the length and the width. So we've not even been given any information in terms of actual numbers here of the length or the width. I can create the same equation I had before, perimeter equals, and then how I would work out the perimeter. Now you might think, oh yeah, okay, I've got the, let's say length and width. You can use whatever letters you want, it doesn't have to be x. However, if I use those 2 different letters, if I have 2 letters in an equation, I can't solve it. I need that many equations. So that's why you have simultaneous equations, right? Where you have x and y, you have 2 equations. Well, I guess I could create 2 equations, but I think that would just be a bit more complicated. The most obvious equation that I could create is the one we just said. Perimeter, so 64, is equal to, and then all of the sides added together. So what that tells me is I would ideally just have 1 letter. So I'll show you how I'm going to do that. I always label the smallest thing x, for example, whatever letter you want. So the smallest side is obviously the width here, isn't it? That's x, that's also x. Now the length, I'm going to say the length is this longer one. I want to write that in terms of x. Obviously it's not also x, is it? Because they're clearly not the same length. I know it's not drawn accurately, but you can assume they're not the same length because they've told us in the question that the length is 3 times the width. So if the length is 3 times the width is x. Think about how could I write the length? with an x, but be the right scale? Well, if it's the length is 3 times the width, then that just means 3 times x, doesn't it? As in 3x. So that's what I'm going to do. I'm going to use everything in terms of one letter, just so I can stick with one equation. So I'm going to do the same thing as before. Obviously, I know the perimeter is 64, so I'm going to have 64 equals 2, and the way I would normally work out the perimeter is just add the sides together, isn't it? So x plus 3x plus another x plus another 3x. I've created my equation. I can almost forget about the context for a second and just go, right, let me just solve that equation. The right-hand side, I can collect the like terms. They're all x's, so I just need to add them together and count how many there are. So there's actually 8x there. 64 is still the same. And now I want to solve it. I want to get x on its own. So instead of 8x, I just want 1x. So I need to divide both sides by 8. Obviously, 64 divided by 8 is still 8. So x is equal to 8. Now, they've asked for the length and the width. So we know, because x was the width, wasn't it? The width is 8. However, don't forget that you need to go back and work out the length. Okay, fine. If x is 8, what is 3x? Well, obviously that's going to be 3 times 8, isn't it? So 3 times 8 is 24. And that is the length. So just go back and input whatever you've worked out x to be into this relationship, which is 3 times. So 24 centimeters. Okay, so that one's a little bit trickier in terms of figuring out how to write it down, as in not in words, but like mathematically, algebraically. Hopefully that makes sense in terms of using x as the smaller side and then multiplying it however many times you need to get the bigger side. Now we've got 2 shapes here. So it says the perimeter of the square is the same as the perimeter of the rectangle. Okay, so they have the same perimeter. Now that sentence is going to be our equation right there. Wherever you've got an is, that basically means equals to, doesn't it? So that's how we can use this information to create an equation. So work out the width y of the rectangle. Okay, looking at the square. A square obviously has all of the same sides, doesn't it? The square, that's just the definition of a square. All of the sides are the same. So I've got 5 here, 5 at the top and 5 on the right. So I could just go ahead and work out the perimeter of the square immediately. So the perimeter of, try and draw a square there, is 5 plus 5 plus 5 plus 5, or 4 times 5, however you want to write it, 4 lots of 5, that gives me 20. Okay, well that's the left-hand side of my equation, isn't it? If you think about it like that, perimeter of the square, which is 20, is equals the same as the perimeter of the rectangle. So the perimeter of the rectangle, a bit more obviously a rectangle, I'm going to write it in terms of algebra. So I know that this side is obviously also 2, and that has to be also y. So I've got 2 plus y plus 2 plus another y, which if I simplify it, collect the like terms, I get 2y plus 4. So, and the perimeter of the rectangle is 2y plus 4 for now. Do you see how I've created that equation? I can now write that as 20, as in the perimeter of the square is 20, is equal to, is the same thing as, the perimeter of the rectangle, which is 2y plus 4. That's my equation now. And again, we're just solving it. We're just going through algebra and we're solving equations. So I need to solve it for y. So I'm going to move, obviously, the 4 first. It doesn't really matter. You can do the 2 first if you want, but I prefer to do the 4. Minus 6, that's the opposite of plus. So I get 16 equals to 2y. And then I'll bring it over here. We now need to divide by 2, don't we? Because we want just one y. I don't want 2 lots of y. So 16 divided by 2 is 8y. So it says work out the width y of the rectangle. Well, that is it. It's 8 centimeters. Okay, so yes, this topic was perimeter, but a lot of the time, because they need to make it, I guess, a little bit more complex, a bit more of a problem-solving question, they like to combine algebra and geometry or shapes together. And I think a lot of people are kind of thrown off by that because they don't expect maybe 2 topics on your syllabus to overlap in the same question, but they definitely can and they definitely will. Okay, so this question, we've got the perimeter of the semicircle is 48.9 centimeters. Work out the diameter. So this one's a bit more complex. We've got a bit more of a complex equation to set up because if you've seen the video on just circumference of a circle, we go through working out the perimeter of a semicircle. We need to reverse all of that. So normally how I work out the perimeter of a semicircle is obviously I'll do pi times diameter, which is the circumference of the whole circle. Because it's a semicircle, I'll half it. And then I have to add the diameter, don't I? So I'm going to just put add d again. That's my, if I were to write it down as a formula, that's actually the formula to work out the perimeter of a semicircle, isn't it? Now, you don't have to memorize that as a formula, because as long as you know the formula for the circumference of a circle in general, you can kind of logically work through it and go, well, I know it's half of that, so I'll divide by 2, and then I know that I've got another side to add on, which is obviously the diameter. But in this case, I'm going to write it as a formula, and I know they've told us that that equals to 48.9. Now, we actually want to solve this to find the diameter, don't we? That's what we're looking for. As you can see, this is definitely a higher tier question, because can you see how we've got the diameter in 2 separate places? And it's quite tricky to go, well, obviously to solve it, I want to get just one of the diameters. I don't want to see this letter twice. I want it to be just there once. So you could rewrite it as the coefficient, or the number that's in front of the diameter, is pi over 2, because pi is a number, isn't it, ultimately? Pi is a number, we want half of pi over 2, d, plus, and this is technically then 1d, isn't it? 1d. I write it like that, you can see it's a 1. That's another way to visualise it. So, if I were to add them together, they are like terms. It doesn't look like it because you've got a pi, but ultimately remember, pi is just a number. It's not a different letter or something. So if I were to add them together, I've got pi over 2 plus 1, or you can imagine it as if you were to factorise, the letter D is the common factor, isn't it? So this is definitely higher tier, this rearranging, because then all I need to do is just then divide by all of this to move it across. So I get diameter just on its own is 48.9 over pi over 2 plus 1. And then I can obviously put that in my calculator. Now, you might prefer to just work out, okay, what is pi over 2 plus 1, and then write that as a number, but you're going to get loads of decimals, so that's why I've left it in terms of pi, because, yeah, you could write down 2.57, but I wouldn't want you to kind of cut off all of these decimals. So that's why I wrote it down as pi over 2 plus 1. It looks a bit more complicated, but I'd rather write it like that than write down decimals and miss any of them out. So now I'm just going to go straight in and write down what I've put here. So 48.9 over, you can put another fraction within a fraction, that's fine, pi over 2 plus 1. That's exactly what I got there, isn't it? So now I can actually round this now because this is the final answer, so it doesn't matter. I'm not going to get any rounding errors at this point. So I've got 19.021. If I were to round it to one decimal place, it'd be 19.0, wouldn't it? Or just 19. Let's just call it 19. Okay, so the nearest whole number was 19. So for this one, the perimeter of the sector is 30.3 centimetres. Work out the angle. So we've actually been given the radius, we want to know the angle. So I'm going to write out, I guess basically build my formula for perimeter, because we haven't exactly memorised a formula, have we? But when I work out the perimeter of a sector, I obviously do the arc length, which is pi times diameter times the angle over 360. You might use 2 pi r, that's absolutely fine. And then after that, we have to add on 2 lots of the radius, don't we? Because it's like a radius here plus another radius here. Now, I ideally want to only have one letter, because I can't solve an equation if I have 2 letters. In that case, you'd need simultaneous equations, wouldn't you? You'd need 2 equations for 2 letters. So I've already used d here for diameter, and actually, radius plus radius is obviously 2 radius, which equals the diameter, doesn't it? So in this case, I'm going to put plus the diameter. If you're using 2 pi r at the start, put plus 2r. Okay, so just whichever letter you've gone with for your formula, stick to that. So we're technically adding a diameter, aren't we, if you think about it at the end. That's the perimeter of this sector, which we now know is equal to 30.3. So I'm also going to sub in the other thing. I know the radius is 8.2. If my radius is 8.2, my diameter is 16.4, isn't it? 2 lots of that. So I'm going to sub that in. Again, if you're using 2 pi r, sub in just 8.2 as it is. So I've got pi times 16.4 times theta, which I don't know. You could use another letter if you want. You could use x or whatever, but I'm going to leave it as just that symbol. Plus the other diameter, which is 16.4, and that equals 30.3. I think the easiest thing to do is to move the 16.4, isn't it? Let's just subtract that straight away. Take that away because obviously it's currently added. So then my brackets will open up. I've got all of this times together, which equals, so we've got 30.3 minus 16.4, which gives me 13.9. So we've got 13.9 here. Now, obviously, I'm trying to get to the point where I've got the theta, this angle, as my subject. So I think what I might do now is times both sides by 360. Because all of this is already multiplied together, I don't need to worry about the left side, it will just cancel it out, won't it? But I obviously need to times the right hand side by 360. So 13.9 times 360 gives me 5004. So I've got effectively pi times 16.4 times theta equals 5004. Now you might do this next bit in 2 steps. You might divide by pi and then divide by 16.4. That's fine, or whichever way round. However, because these two are multiplied together in themselves, I can just divide by both of them at the same time. So that's what I'm going to do. I'm going to take my 5004, divide it by, and I'll just put a little bracket, pi times 16.4. Okay, you can do that. Because when you times multiple numbers together, it doesn't technically matter which order you've times them in. So I'm just going to move them both across at the same time. So I've got for theta 97, and if I do it to 1 decimal place, 97.1. So therefore theta is 97.1 degrees. And that is to 1 decimal place. Okay, so with these ones I would definitely set up an equation first, so that you can then quite clearly just focus on the algebra rather than having to figure it out off the top of your head. So now we have covered everything on perimeter. If you would like to go back and check out any of these previous videos, they will be all linked down below. Otherwise, the next thing to look at will be area. So thanks for watching this video. If you found it helpful, please make sure to like and subscribe. And if you have any questions or anything you're not sure about, definitely leave down below any comments that you might have.